All right, so today's submission is from a calculus student in college, and essentially what we're going to be going over is secant lines. Now, a little bit of a backstory. Secant means to cut in Latin, and the significance of that is that a secant line is essentially a line that intersects a function at two particular points. So let's just say here, and let's say here. Now, for my algebra students, this should look pretty normal, right? Because this is actually going to be just finding the average rate of change between 2 points, also known as finding the slope. Now, why is this significant in calculus? Well, calculus is the study of instantaneous rate of change, or in other words, rate of change at one particular point. So eventually we're going to start converging these points together closer and closer until we get one particular point. But all of that aside, let's get right into these questions here. So let f of x equal 8.6 x squared minus 9.1x. Find the equation of the secant line given x sub 1 equals 7 and x sub 2 equals 16. Okay, so like I said before, we are finding the average rate of change, right? We're finding the slope. Now, slope is y2 minus y1 over x2 minus x1. Now, I'm going to be honest, I don't really like teaching formulas that much. I like to teach concepts a little bit more. So this is actually the change in y over the change in x. The way that I like to teach it is, imagine I am right here. I'm at the origin of this graph, and you're over here. And I'm blindfolded, and all I have is a phone. And I'm trying to get to where you're at. How are you going to direct me to where you're at? Well, you're going to tell me, hey, go up a certain amount of steps, go to the right a certain amount of steps. Why? Well, I'm blindfolded, right? So if you tell me diagonally, I might go over here, I might go over here. There's so many different places I can go. So the most convenient way to teach me is to tell me to go forward, because I can't mess up going forward, and to go 90 degrees to one direction, right? Slope is the same exact thing. It's just telling you how much you have to go forward or backward, and how much you have to go left or right. And the way that we do that is we find the distance between our y values and the distance between our x values. So we got our x values here, 7 and 16. So what I'm going to do is I'm going to write the fraction out. 16, I'm going to write it at the bottom, minus, right? I'm finding the distance in between them, 7. Now, you don't necessarily have to do 16 and 7. You could do 7 and 16. The order doesn't matter. What's important is that if you put 16 here, the output of 16, in other words, 16's y value, has to go directly on top of it. Now, how do I find the y value here? Well, a function, I like to think of it like a vending machine, right? If I put in $1 or so into a vending machine, I get out a pop or whatever I was trying to get, right? X is our dollar in this situation, Y is our pop. So if I have 16, I'm going to put 16 into the equation. So basically everywhere there's an X, I'm going to write 16 here. And whatever number I get out is going to be my Y term. Now in this case here, when I multiply it by 16, I'm going to end up getting 2,056 minus, I'm going to do the same thing with 7. Right now I'm inputting a different value, and that's going to give me 357.7. Perfect. Now I have it set up. I have the distance between my y values and the distance between my x values, so I have the slope. So now from here, all I'm going to do is some math, right? 2056 minus 357.7. Let me do this on a calculator real quick. 256 minus 357.7. Okay, I got 1,698.3. Over. Okay, now I have 16 minus 7, which is equal to 9. Cool. And then I'm going to divide these terms together, and I'm going to get 188.7. So this is my average rate of change, right? This is my slope. Now, from here, I have a point, right? This essentially is a point in and of itself. That's an x and y value. This is also a point in and of itself. That's an x and y value. So I have a point and I have a slope. So I can use point-slope form, which is y minus y1 is equal to m times x minus x1. Okay, from here I'm just going to plug my numbers in, right? I just found the slope, right, which is 188.7. So I'm going to rewrite this with 188.7 instead of m. Now, since this is a line, right, the line's going to be the same no matter which point I use. So it actually doesn't matter. I just have to stick with one point. I'm going to do 7 and 357.7 because the numbers are smaller. I don't feel like dealing with big numbers. So put an x here, minus, in this case, 357.7. Oh, well, actually, x minus 7 here. Almost messed up there. X term right here, right? The bottom was the x term. And then y minus 357.7. Cool. Now I have my equation set up. From here, smooth sailing, right? All I'm going to do is just a little bit of math, and I'm going to multiply out. So this is going to be equal to 188.7x. 188.7 times 7, no idea. 188.7 times 7, okay, minus 1,320.9. And then I'm going to add the 357.7 to the other side, right? Inverse operations. And that's going to give me 963.2. So y is equal to 188.7x minus 963.2. And that's my answer to the first one. Now we have 3 questions here, so we go on to my next one. Find the average rate of change of this function. Now here, the idea is still the same, right? Average rate of change, slope, all of these mean the same exact thing. So it's still going to be y2 minus y1 over x2 minus x1. Same thing here. So I'm going to do the same thing. I'm going to put 1 minus 0 because these are my 2 x values. Very important thing to note here is that these inequalities are equal to, meaning including, right? It's 1 and 0 are included. If it wasn't, if this was just x is less than 1 and x is greater than 0, then I have to choose numbers other than those that fit my parameters. Well, in this case, we got a little bit lucky. Cool. So now, what am I going to do? Well, I have my coins. I got to put them into the vending machine. So 1 squared is 1, plus 5 times 1 is, this is going to be 1 plus 5, which is 6, minus 2, so this is going to be 4. So when I plug in 1, I get 4. Again, notice how they're vertically right on top of each other. 0, 0, this is going to be negative 2. Now, it's minus negative 2, which means plus 2, right? That's a double negative. That's like saying, do not put on your shoe. You mean put on my shoe, right? Same thing here. If I'm double negative, it's like, so you mean add. That's kind of what's going on here. So my average rate of change here is going to be equal to 6. That's the final answer. All right, moving on to the last question here. Okay, we got somewhat of a word problem here. If a ball is thrown straight up into the air with an initial velocity of 85 feet per second, its height in feet after t seconds is given by y equals 85t minus 16t squared. Find the average velocity for the time period beginning when t equals 0 and lasting 0.1 seconds, 0.01 seconds, and 0.001 seconds. Finally, based on the above results, guess what the instantaneous velocity of the ball is when t equals 2. Right here is when we're getting to that tangent part. But let's not get ahead of ourselves. So, first thing I'm noticing here, average velocity. If we go over here, average rate of change, right? That's what we're dealing with. So it's the same type of idea here. Anytime it's like the average distance over time or something like that, that is screaming slope at us. So we need to find the slope of this, of a secant line based on this graph. Now, that means that there's a y2, y1, x2, and x1 value given to us. So we have to find it. All I'm seeing right now is t equals 2. Cool. That's my first value. Now, since this is time is equivalent to our x values. The reason why is because height, logically, goes up and down, right? We don't ever think of height as left and right. So that's our y values, meaning that time must be our x values. So I'm going to put 2 minus 2. And now where's my other x value? If you think 0.1, that would be logical, but it'd actually be a mistake. And the reason why is because if we read this carefully, for the time period beginning when t equals 2 and lasting 0.1 seconds, that means it's basically 0.1 seconds after the beginning of 2 seconds. So it's not going to be 0.1, it's going to be 2.1. And then from here, we're just going to plug in these values, right? We're going to pop that quarter into the vending machine. So here, I'm going to plug in my values. So 85 times 2.1 is, no idea, 85 times 2.1, 178.4. I don't have to write that down actually. Minus 16 times 2.1 squared, which is 107.94. And now I'm going to subtract. Again, I'm plugging in 2 here, so 85 times 2. 170 minus 2 squared is 4. 4 times 16 is 64. So minus 64. 106. Okay, so then I have 107.94 minus 106, which is 1.94, divided by, looks like 0.1, which is just a decimal move, meaning that our answer is 19.4. Okay, so right here, 19.4. Now for the rest of these, we're going to do the same exact thing. And I'm not going to bore you, so I'm just going to give you the answers for all of these. The next one's going to be 20.84. And then the final one here is going to be 20.984. Now notice that there's a trend going. We are converging on a particular number here. And that is what this final question is asking us, which is guess, right? Guess what it is. Well, if we look, 19.4, okay. We're increasing, 20.84. Okay, we're increasing at a slower rate though, 20.984. I would assume that this is 21, right? And what are we doing? Well, basically, what we're doing is we're trying to find the slope between 2 points, right? Right here. But what if I want to find the slope at an instantaneous point? In other words, 1 point. Well, a good way to do that is if I keep on bringing it closer, all these values, let me kind of zoom in here. What if I keep on bringing these dots? Let me delete this too, this is ugly. Okay. What if I keep on bringing these dots closer and closer together, right? I'm converging on this point. Well, that means I'm going to get more and more accurate with the slope at this particular point. And that's essentially what we're doing here. Now, as this student gets more into calculus, he's going to learn how to do it perfectly without having to use 2 separate points and then doing 1 point. But for now, especially for my algebra students, this is why it's very important that we learn rate of change, because this is an idea that's going to follow you even into upper level calculus and on. All right. Well, that was it for today. Thank you guys for watching, and I'll see you guys on the next one.